I'm Patrick Ruimerman. As I said, I work for a BTG. BTG Biomass Technology Group is a company that is an SME located in the Netherlands. And we have as our focus dedication to energy and materials produced from biomass. We consist of two departments, a consultancy department of which I am a part, and an RTD and development department that is about research and technology development. As I said, we have our own laboratory where it's mostly focused on thermochemical conversion of biomass. And we think this is a very good combination because the RTD is doing the new technologies and consultancy is very close by. And we from consultancy are able to tell RTD what is really happening in the market. So we think that this is a very good combination of two distinctive activities. We have a lot of experience and a great track record on projects. Several companies were established, lots of plans realized, many projects. On the project spectrum, we work from the start, like the pre-feasibility, up to the implementation and the monitoring, so all those activities. We span the entire value chain from feedstock assessment to the use and production and use of materials. The availability of biomass we know about logistics and pretreatment. Of course, we know about the many conversion technologies and about market research we do regularly. We also pride ourselves on gamma aspects such as sustainability, of course, life cycle assessment, value chain evaluations. We know a little bit about financial evaluation, economic evaluations. We know about legal aspects, and also we try to do some things on knowledge transfer, education, and disclosing the knowledge which is all omnipresent everywhere. We like to work in European projects. We have experience with the formation of the consortia and with the cooperation there. We are open to work with others on this field, and we're open to lend our expertise and work together and make very nice projects, such as the Aligned project. Because the Aligned project, how did it start? Well, it started with a study on biorefineries, which we did for the European Union. And they wanted to know what the outlook is for biorefineries in the not too distant future. And one of the things that we did there was to look for the barriers towards further biorefinery implementation. And then sustainability, and especially the evidence of sustainability, is an issue. There are not just one problem, but several problems with that part. First of all, it's costly. You need often a full life cycle assessment, and that needs to be done for each project separately because it has separate value chains. Sometimes it's open to interpretation. Everybody does it in its own way. The fossil competition doesn't have to do that because they just sell their products. So no level playing fields. There are many labels which sometimes mean a thing, sometimes not. We have sector-specific methods like the Higgs MSI for textiles. The terminology is confusing. What is biodegradable, biologic, etc., etc. And we thought, well, this needs to be done better. So the European Union, thankfully, also thought this, and they issued a call to try to improve the environmental sustainability of industrial bio-based sectors. And we gathered a consortium of about 10 partners, and the Aligned project was born. And the idea of the Aligned project was to advance the life cycle assessment field, work with industries in 5 industrial bio-based sectors: construction, woodworking, pulp and paper, textile, and biochemicals. And of course, we are here with the biochemicals. And it's no secret why we have these 5 sectors. All these sectors use, of course, biomass, and biomass is a finite resource. So they are, of course, also in that way quite linked to each other. Well, we have some objectives, which are quite ambitious, of course. We want to improve, harmonize, align LCA methodologies for the assessment of these industrial bio-based industries. We want to demonstrate how these methodologies that we are worked on, how they could improve the environmental performance. And what we do, of course, in this stakeholder workshops like this, inform, involve, and empower relevant stakeholders so that we get a good uptake and also that we are doing the right things. We have a nice partnership. It's a combination of several universities, from Aalborg University, who is the coordinator, to the Antwerpen University, INSA in France, and NTNU from Norway, and Nari is part of that. We have 5 case studies where we test our methodologies, and Kingspan is one of them. Foreco is for the wood sector, Bloom and Utexbel, and for the biochemicals it's Oleon. It's an oleochemistry company. 2 research SMEs, BTG and Sustainable Innovations, and 1 sector organization, which, as you can see from the logo, is from the textile sector. It's Centexbel. Good. Then about our methods. What we wanted to do is we wanted to ground our theories in scientific literature and use that in the real world and practice it in the real world. So this is the overlapping part of the 2 Venn. It's like a Venn diagram. We are in this overlapping part. We wanted to be openly available, and we wanted these methods to be applied and tested in the case studies, and of course applicable across all these 5 sectors. That was the goal, of course, hence the aligned name. Well, what are those? Roughly 5 methods which we developed or promoted. The first one is also already tested by Nari, for example. A method for generating dynamic background data for prospective LCA, especially for technologies which are yet to be developed. If you compare that in an LCA with today's data, then you will probably not get the right results, because in 5 or 10 years, our energy generation capacity will be, hopefully, a lot more sustainable. Well, the dynamic background data, that's a method where you use a premise to get a new database with these updated data, and that hopefully gives a better indication on the environmental sustainability of these future technologies or products with a very long use phase. Nari will tell about how she applied this, and also what is good and what is a bit less good there. The second one, on the LCI, the lifecycle inventory, we have a method for identifying the market constraints. And we think that in many cases an attributional LCA is not really suitable. So we would like to have a consequential LCA where we use market data to determine what happens in the market when our project or when the project or the product is being introduced. So we have a method for identifying market constraints for the biomass, which is, of course, key in our industrial bio-based sectors. Besides that, we have a method for time and space dependent carbon accounting. You will remember, or you will know probably, that you can neglect the carbon, or you can just add and subtract it in one figure, but you can also do it dynamically, time and space dependent, and that is more accurate in some cases. Then in the LCIA part of it, we have two methods. Namely, one is for the dynamic assessment of climate change, uptake release of CO2, what happens there for the climate. And we have also a method which we sadly could not test because of our case studies didn't allow it, to look at biodiversity impacts. This is, of course, still a bit of a gap in life cycle assessment. We experimented with several methods for uncertainty and sensitivity analysis, and we worked on a method for socioeconomic assessment in bio-based sectors. These methods, they are all open. We have written tutorials so that you can use them. In Zenodo, the slides will be available after the presentation, and it's also on our website. But description of our methods is found on Zenodo with the tutorials. There is a tiered approach possible. So, for example, for prospective LCA, you have a tier 1, tier 2, tier 3 approach. Tier 1 is for the quick and dirty approach. Tier 2 is a little bit more elaborate already. And if you really want to program yourself, you can do tier 3. So we wanted to make the application of these new methods as easy and as transparent as possible. We hope that worked. And at least what we want is what we would like to have is your feedback on this. You're very welcome to try them. And with this QR code, you can provide feedback on your user experience. And we would really encourage you to do that. That will help the projects, the methods to become better, the tutorials to become better, and makes life easier for all of us, we hope. Our case study is about Oleon. It's one of the leading producers of oleochemicals. It's about the bio-based ingredients, and the main question in the case study is about the use of different vegetable oil feedstocks and, of course, the environmental sustainability consequences of that. This workshop, lastly, it is about the consultation of you on our methodologies. We did 2 years ago a similar workshop where we explained our methodology. We talked about the sector and the environmental sustainability in this sector. And now we're ready to present the results. We hope that you enjoy it, and we hope that you will give us feedback and input on what we are presenting and what you think about that. So we think that's very valuable. So I would like to thank you already for providing that. And lastly, if you can't get enough of it, you can get connected with us in various ways and quite easy. So I wish you a very good workshop and hope that you enjoy this. Thank you. And now I would like to give the word to Nari. Nari Souza works at the NTNU, and she will talk about one part of the biochemical workshop. Nari, please take it away.
Thank you, Patrick. I think everybody can hear and see my slides, right?
At least I'm doing it, so
okay.
Yes.
If not, please just say something, because I lost the... Yeah, I saw one hand. Okay, so thanks for the introduction, Patrick. As you mentioned, I will talk about the potentials for sustainable expansion of the bio-based sector, bio-based chemical sector in Europe, and I am a postdoc at the Norwegian University of Science and Technology. Okay, so before I go to the this study itself, I wanted to bring a bit more of background. So the chemical sector in Europe, it's mostly linear and heavily fossil-based. And in this sector, the fuels, they are used both as an energy source and as a feedstock So the carbon molecules, they stay in the polymers. And then we cannot talk about decarbonization because we need the carbon. So we should talk about the fossilization. And this also towards a circular economy where we reuse and recycle most of the polymers, which are plastics produced, because currently the waste management of plastic waste it could be better. But then the chemical sector has a difference because there are not so many renewable feedstocks available, differently from the energy sector. For example, we can have solar energy, we can have wind energy, but in the chemical sector, we rely on carbon sources. We can have organic, solid, or organic residues. We can have directly from the carbon dioxide molecules. We can have the recycling of the plastic already produced, or we can use biomass. But biomass is a limited resource. We have also other sectors that are relying on the decarbonization based on biomass. And specifically for the chemical sector, usually some of the alternative bio-based products, they are in a low technology readiness level, which is something Patrick also mentioned in the introduction of the project. So I go now to this first paper that we published in this work package, where we discussed the challenges and opportunities towards a sustainable bio-based chemical sector in Europe. You can access it via QR code. It's here on the top of the screen. It's open source, so you can just access it. But basically there we had the overview of the European chemical sector, and we identified 5 main sustainability challenges, which is circularity, climate neutrality, to have a toxic-free sector, to end the pollution, and then in the impact assessment because of the low technology readiness level. But then biomass can both bring some opportunities, but also can add some extra challenges. I won't go into details here because, as I said, this is published. You can access and read it with more time. But I brought it as a context and background for what I'm doing right now. So for the potentials for the sustainable expansion, we have some research gaps and proposed solutions. The first of all of them is it possible to replace the fossil polymers currently produced in the EU with bio-based polymers in a sustainable way? So that not only climate change impacts, but also toxicity, pollution, and the level of circularity. But then a second question comes up, which is there enough biomass? So when we're talking about the full sector, the whole sector, we wanted to look for the residue biomass in Europe, not to compete with food because it's a large amount. And then because biomass is a limited resource, then we have to target which are the polymers of most concern so that we can select them to be replaced by bio-based alternatives and mitigate their environmental impacts. So this is the second question, what is the environmental mitigation, or if there is environmental mitigation? For that, we apply a life cycle assessment, comparing the fossil against the bio-based options, and the methodology of prospective life cycle assessment. As Patrick mentioned, it's the one developed the tutorials at Align project that you can also find at Zenodo, the guidelines to also apply this methodology yourself. Quickly, I wanted to understand what is the current production of fossil counterparts and which polymers we're talking about. So this is based on Eurostat data, which is also publicly available. This is an average of 10 years. And as we can see, Germany and France are the countries with the largest production. And we have polyethylene, polypropylene, and polyvinyl chloride as the largest produced polymers. The sum up of all these polymers is around 37 million tons of polymer per year. And then, okay, what is the residual biomass availability? As a coincidence, we also have Germany and France with the largest amount of forest residues, agricultural residues, and some municipal organic waste and industry waste. For example, the beer residues and milk residues. And then we have here that the agricultural residues is the most available resource, which totalizes around 250 million tons dry bases per year. But then we go to the question that I said, is there enough biomass? So what this amount of biomass means? We performed some preliminary estimation to replace those 37 million tons of polymers, and we would need around 280 million tons, which is more than the preliminary estimation that we would need 250 million tons. And we also have to think that most of these residues are already in use. Some industries, they burn their residues to generate heat and power. Also, some of these residues, they can have potential economic and technical barrier to produce polymers. So it's already not enough, the biomass, plus some other technical and economical restraints. That's why we need to target which polymers should be replaced by the bio-based ones instead of just pretending we can replace all of them. We adapted this conceptual framework by Sue and colleagues that they have 4 main criteria to identify which are the fossil polymers of concern. And then here in this study, I assessed climate change, toxicity in 2 different methods, ecotoxicity from environmental footprint and human toxicity from use tox. And then circularity and pollution, they are qualitative based on literature review. And we also have one addition that is the desired characteristic of the bio-based alternatives for each one of the polymers. So I bring today just one example. I think there's time limitation and also not to be so boring. But then you can stay tuned for the results of other polymers. But then polyethylene, it has a high climate change impact. So by kilo of polymer, the climate change impact of polyethylene, the fossil one, is not super high, but because polyethylene is the largest produced polymer, so then we have one of the highest climate change impacts weighted based on production compared with the other polymers. There is a medium toxicity, so the polyethylene doesn't bring a high toxicity. The circularity, the polyethylene is one of the most recycled polymers in Europe, but not all the polymer is recycled. As I mentioned very in the beginning, the circularity of plastic waste could be much better in Europe. And polyethylene has a high pollution compared to the other polymers because it's one of the most polymers found in nature. So then how can the bio-based polyethylene help solving this issue? As I mentioned, stay tuned for the aligned results of the other polymers. Today, I just bring polyethylene. So bio-based alternative of the polyethylene could be a drop-in polymer, which means it has the same molecular formula as the fossil counterpart, but by being bio, we could have a reduced climate change impact. For the toxicity, a drop-in bio-based would cause the same toxicity impact because it's the same molecular formula. So a dedicated bio-based polymer could be a better option. One example of a dedicated bio-based polymer is the polylactic acid, PLA, that usually replaces the PET plastic, PET polymer. So it's a different polymer, but with same functionality. As of circularity, the bio-based polymer could be a recycled drop-in or dedicated bio-based polymer. And pollution could also be a drop-in or dedicated and biodegradable, so we would reduce the amount of polyethylene found in nature. Yeah, so going a little bit more into the bio-based polyethylene that I'm considering. So it's based on the replacement of the fossil ethylene, which is the monomer for this polymer, with a bio-based ethylene produced from forest residues. So I use data from Humbert. And then the dehydration of ethanol to ethylene is also based on literature. And then polymerization, because it's a drop-in, it has the same chemical formula. The polymerization is from EcoInvent database. And the market for this polyethylene considers a share of high density, low density, and linear low density, just to say that I'm considering this market specificities. And then the end of life, there is this share of recycling, landfill, and incineration with energy recovery. And for each one of those, just the incineration that I consider that when you burn this polymer, all the carbon is released as CO2. So this is also based on literature. And then going to the life cycle assessment, a GOE scope, it's a fossil versus bio-based alternative for each polymer. As I said here today, it's polyethylene. It's a cradle to grave, considering end of life, which is very important for bio-based products. It's a carbon balance. I don't have data for bio-based impacts on toxicity. And then it's a 1 kilo of polymer that we are comparing, fossil against bio-based. And then the climate change, toxicity, and circularity impacts and pollution. And then, and then the perspective, which is the, let's say, novelty. We have EcoInvent 3.9.1 cut-off version using premise that transforms the databases. And I'm using SSP1, SSP2, and SSP5, which are the shared socioeconomic pathways. These are sensitivity scenarios for an optimized world, which would be the SSP1. Business as usual will be the SSP2, and a fossil-based future world would be the SSP5. And then for the years 2030, 2040, and 2050. A sum up of the methodology, I have these 4 steps that I showed in the previous slide: the production of fossil counterparts, biomass availability, replacing fossil polymers, and then the life cycle assessment. Going now to the results, in the first panel, I have climate change impacts. The black one is the fossil polymer, and then the gray is, the blue is the SSP1, so the optimistic scenario. SSP2 is the business as usual, and then SSP5 is the pessimistic. And here I already give a spoiler. SSP1 baseline is not more optimistic than the business as usual, considering the nationally determined contribution and the NDC. So this is an adjustment that I'm performing now that we saw with the results. And then panel B, so the second one, the middle one is ecotoxicity, and the last one is human toxicity. As I mentioned in all the slides, we will have results for other polymers. But the climate change, basically, as we advance to the future, we have a reduction coming from improvements from the value chain. But then the SSP5 is fossil-based, and then it's worse. But then we have a mitigation compared to the fossil one. But then for toxicity, because premise is focused on climate change, we have a trade-off. So the toxicity from the bio-based product, the polymer, it actually increases. So coming from the biomass transportation and the enzyme production. In summary, the climate change, the drop in polyethylene has potential to reduce the impacts in the future, but the toxicity, as we saw, we have a little bit of increase of the impacts in the future. The circularity and pollution, a drop in bio-based ethylene cannot solve it, but it's more related to the waste management of polyethylene and all the other polymers than the feedstock itself. So being bio not always will improve the circularity and pollution of polymers. And some final remarks and learnings from the perspective, from applying the prospective life cycle assessment, is that the bio-based options, they not always solve all environmental issues, but it's very important to assess climate change, toxicity, pollution, and circularity. They are the largest challenges of the chemical sector in Europe. There is a lack of data of end of life, mainly for the bio-based alternatives. We don't know toxicity impacts, for example, from these new bio-based polymers. The integrated assessment models for the prospective life cycle assessment, they focus on climate change. So then there are some trade-offs with toxicity, as we could see in the graph. And some of the sectors transformed doesn't include the chemical sector in this future, so the prospective LCA. So the main molecule of each polymer is bio, but all the value chain remains fossil for the chemical sector. And as I gave the spoiler, SSP1 should be the also nationally determined contribution to be a better option, more optimistic. So I showed SSP1 baseline, but then this was not more optimistic than the business as usual, that is SSP2. And with that, I think I am just on time for my presentation. So if you have any question, if you want to talk to me after, please feel free. So thank you.
Thank you, Nari, it's very interesting presentation. It's nice to see how you have modeled the transformation of the polymer sector, the bio-based sector. Yeah, I was surprised how much biomass you need for that. But yeah, apparently we use lots and lots of plastics. Yeah, and also you showed a little bit the limitation of the prospective modeling. It's good for climate change issues, but a little bit less for these chemical issues.
Yeah.
So very interesting. Yeah, that's. I hope we learned all something. Is there anybody who has a question or comment? I mean, yeah, we will have a discussion later on many things and this as well. But maybe already somebody wants to say something or ask something. No. Okay. Good. Well, then thank you, Nari.
Welcome, thank you.
Yeah, thank you. And we go to the next presentation of the case study. Jurjen Spekreizer of BTG will tell us about the Oleon case. Jurjen, I already see your screen, so I would say take it away.
Thank you very much, Patrick. Yes, as Patrick mentioned, I will go into a more specific case study. I hope to make it a little bit more clear how you could apply the light methodologies yourself as well if you have a case study. And I'll do that using the Oleon case study that we used in the Align project. Of course, this partnership with BTG and Oleon within the project. And we've been working on this case study since 2022, so we're nearly finished. And our approach is quite straightforward, as you'd expect from an LCA. We first have to look into the case study. So what are the boundaries, etc. Then we performed a standard LCA, so how you would normally do your LCA. Then we went to do a consequential LCA to compare the differences there. And then, as Patrick mentioned, the Align tools are all on consequential LCAs. So we applied some of these Align tools on our consequential LCA. So first, the case study, it's about oleochemicals and specifically hydrogenated dimer acids, which is an important activity from Oleon. It's a product that in the end goes into different types of polymers. You can think of polyamides, polyesters, epoxy resins, etc. It's not a product that has a fossil-based alternative, so it's really a dedicated bio-based product that is already currently produced on large scale. It uses rapeseed oil, so Oleon buys in rapeseed oil. They have a couple of chemical conversions, and then they end up with a high purity product, which they then sell to customers, which convert these further into the chemicals that go into the polymer applications. So if we look at that from a value chain perspective, you can see the value chain here, where we start, of course, with the rapeseed cultivation on the left by farmers. They produce the rapeseed, which is sent to suppliers of Oleon. They press the rapeseed, they make rapeseed meal as a side product, and the oil goes to Oleon. And after chemical conversion, they make the HDA, and that is converted to many different products by different customers to end up in the different polymer applications. During the chemical processing, there are several fatty acid derivatives as side products that find other applications. So on this value chain, we can do our standard LCA. So you can think of an attributional LCA. We have a cradle to gate. Since you have so many products, it is not feasible to do the fully use phase and end of life. Our functional unit is 1 kilogram of HDA produced at Oleon, and you can see the database and calculation methods. So from that, you get a quite straightforward answer. So this is a division of the global warming potential of this value chain, quite simply divided into the biomass cultivation, heat, electricity, transport, waste, and the remaining processes. And you can see from this sort of standard LCA approach, biomass has a large share of the impact, and also the heat that is used during the pressing, during the conversion, and also there's some heat at the waste conversion. And together that makes up for 80% of the total impact. So this is a very useful input for Oleon. They also use this to further improve their processes to reduce their global warming impacts. But we want to take a step further and do a consequential LCA. The first step is quite simple. Of course, we need to have a consequential data set. So we switch to the consequential records from EcoInvent. We need to apply system expansion. So where with the attribution LCA, we had allocation on several steps. We need to now perform a system expansion. So you can think of the side products at Oleon. They become products, so they replace virgin vegetable oil. Also at the rapeseed meal, we need system expansion. I'll go a bit more detail on the next slide for that. And then we also have to determine the marginal suppliers. We have an alike methodology available. I won't go into details for this, but I do want to show you the system expansion for the rapeseed meal. Because this is quite an interesting process where rapeseed is pressed to produce oil, which goes to Oleon, and then we have our side product, which is mostly used in feed applications. So if Oleon would increase their production, they would need more rapeseed oil, which means we increase the rapeseed meal production. So that means we have more production of feed. So in a consequential LCA, we have to compensate for this higher production in feed, which means we can produce less barley and less soybean, which are now the most common products to make feed. This gives a second issue, since soybean is not just produced for meal, but you also have a side product in soybean oil. And the soybean oil is used mostly in food application. So we have a reduction in vegetable oil for food application, which then in our consequential model, of course, needs to be replaced by system expansion. So we expand the system further. The most common vegetable oil is oil palm. So we have a slight increase in oil palm production. Now, of course, you can already see the next issue coming up. When you produce oil from oil palm, you, of course, produce vegetable meal again, which goes to feed, which then needs to compensate it, etc. So you can go through this process a couple of times. Fortunately, these products were not chosen at random. Oil palm is very efficient in producing oil. Soybean is very efficient in producing meal. So after, let's say, 2 or 3 iterations, the numbers become negligible small. So once we applied this into our model, we have a consequential LCA. And I show here the results in a slightly different way. So on the left, you see the attributional LCA, how that relates to the global warming potential. You recognize the large bar in biomass. And on the right, you can see the effect of switching to a consequential LCA, where there's a large impact on biomass now, mostly because we also include palm oil production. And there's in light green also a large avoided production of soybean. So from the consequential LCA, we can conclude that the impact on the vegetable oil market is one of the main global warming impacts when we look at the value chain. If we look at the final results, because it's always appealing to look simply at the number. So if you do the math, you see that for the consequential LCA, we end up at roughly minus 4.5 kilograms CO2 equivalent per produced HDA. So what that means is that an increase in production would lead to an increase in rapeseed oil over soybean, and that reduces the overall global warming potential, since the production of rapeseed oil is less impactful than the production of soybean. So it's mostly a vegetable oil market effect that we see here. And now that we have our consequential LCA, we can apply an LCA method that I want to go a little bit more in detail in, and that's on carbon accounting. Because there's different ways that people do carbon accounting, and then I'm talking about what do we do with biogenic carbon. So there's a very popular method called the 0-0 method, where we say all the CO2 that is taken up by biomass during cultivation will eventually be released as CO2 again. So they cancel each other out. We take them out of the model. Uptake we put at 0, emission at 0. It's a quite straightforward method. It is also very useful when you're applying attributions, or when you do an allocation, you don't end up that your CO2 balance goes off. But it's of course not close to reality. We can go one step further. We can say well, not all the carbon will eventually end up as CO2. Some will, for example, go into methane or CO. Then you simply take the carbon into account. So you get the +1 - 1 method, where you model all the CO2 taken up at -1 and all the emission as +1 CO2 equivalent. However, during the product lifetime, the carbon is bound in the product, and therefore it is not in the atmosphere as CO2. So during the lifetime of the product, there is no global warming effect from this carbon. So we could actually take one step further and also take into account the lifetime of the product and how long the carbon is stored within the product. Now this becomes a little bit more complex than +1 - 1. So for that, we have a nicely developed aligned method. If you go to the Zenodo page that Patrick showed, you type in aligned, you find a list of tutorials. The one I'm showing here is the 1.3 tutorial. On the right, you see how it looks like. And we simply follow this tutorial. Very roughly, it's 3 steps. The first step is to determine the carbon flows. Then we use an align tool to calculate the GWP 100 score, and then we have to integrate that into our LCA. So determine the carbon flows. We actually have an issue, since if you remember the beginning of my presentation, I quickly mentioned that we have a cradle to gate setup. So we don't have the lifetime and we don't have the end of life. So we need to have, of course, our lifetime if we want to take into account the carbon storage during the product lifetime. The solution we took is to take one example application. So in this case, we took epoxy. Epoxy has a lifetime of 33 years. And then the HDA that goes into the epoxy will be there for 33 years. So we have our life cycle phase, where in the first year we have the biomass cultivation, the production. Then for 33 years, the product is used. And then we have an end of life, of course. Then the end of life gives the next issue, since there is no direct data from end of life, since it's so far away from Oleon's production. We solve that with simply taking a European average for this case. So on average, about 17% of the materials in Europe are landfilled, and the remaining is incinerated. We took the quite rough assumption that HDA will behave very similar to vegetable oils in a landfill. So in an anaerobic system, you will get mostly methane. So we had a full conversion to methane of HDA in the landfill and a full conversion to CO2, mostly to also highlight what this does on our model and our results. So then we have a carbon balance where during the cultivation, we have an uptake of CO2 of minus 2.8 kilograms. And at end of life, part of it is incinerated, so that's the +2. And then part of it goes to landfill, which gives you a methane emission. Then the next step is to convert this into a GWP score. This is quite straightforward, since you simply download the Excel file from our Zenodo depository. As you can maybe see, it's a bit small, but there are numbers already filled in. So make sure you remove these numbers. You refill in the carbon balance that I showed. And then on the top right, there's a big orange box that gives you the value. So very straightforward. In our case, it's 3.4 kilograms CO2 equivalent. Do note that this is not a final result. You still have to integrate this into your LCA. That requires a couple of steps. Due to time, I will not go into all the details. But if you simply follow the aligned method guideline, you will get there. It's quite straightforward. Most important, the overall impact of doing this carbon accounting is that our impact decreases with 1.5 kilograms CO2 equivalent per kilogram HDA. So the temporary storage of CO2 in the product really shows a decrease in the impact in the LCA. So overall, what can we learn from all of this? I want to state again what Patrick also mentioned. Find our aligned methodologies. They're freely available, they're user-friendly, and provide us with feedback. I showed you a consequential LCA, identified the marginal suppliers, and this gives you more accurate what the impact is. So it really shows that this cultivation of vegetable oil is one of the main issues in the value chain, or one of the most impactful parts of the value chain. If you actually want to improve your own process, an attributional LCA might still be faster and easier. So there can still be a preference over attributional LCA over a consequential LCA for those reasons. Then I showed you the carbon accounting. I think it's quite important for bio-based chemicals because it really shows how the carbon storage during the product lifetime has an impact on your LCA, and it gives you a much better score. It does give challenges because when you have a bio-based chemical, as I showed you, you have many applications, many different products, many different lifetimes. So there are some challenges in properly do the carbon accounting for bio-based chemicals. And that brings me to the end of my presentation. We'll have a more interactive session now. But if you realize any questions later or when you're driving home this afternoon, feel free to send me an email to the address on the screen. And I'll give the word back to Patrick.
Thank you very much, Jurjen. This was quite interesting. I also very much liked it how you showed how the methods are being used. Before I give the floor to lots of questions from others, maybe, just one question from me. On the end, when you showed how the the dynamic carbon accounting impacts the overall CO2 balance, you noted that due to this dynamic method, the carbon emissions decreased. However, you also noted that there was quite some methane emissions from the landfills. And I would say if you have methane emission release, it's like a factor 21 or 25 for global warming. How do you match that?
Yes, exactly. You're absolutely right. Methane has a much higher impact than CO2. So that increases your global warming potential. But the storage of the amount of CO2 for these 33 years apparently more than compensates the little bit of methane that you form in the end. So it's really the 30 years of carbon storage that in these 30 years, this carbon is not in the atmosphere, so it does not contribute to global warming for these 30 years. And that effect compensates for the little bit of methane that you produce in the end. And keep in mind, this was, of course, quite rough estimation of the impacts of end of life. So it was quite simplistic model for the end of life.
Yeah. Okay. Great. Thank you very much, Jurjen. Is there somebody else who has a question for Jurjen or a remark to be made on the methodologies and his work? No?
Then
Okay.
I think we can follow towards the interactive discussion.
Okay.
I will share my screen. And hopefully everybody has their phone nearby. You can scan the QR code. If it doesn't work, you can also go to the website of ahaslides.com/chemical2, which is listed here. I will quickly show you how it works. You can simply use it with your camera, scan the code, and you will automatically go to the, let's say quiz or questions we will propose. And you can use, just in your browser. Okay. Then we will start with some trial questions. And I will see how many people are joining. So the first question is, what is your field of occupation? Currently, we have 9 people who are joining. And I think maybe we can wait a little bit to see if more people are able to get into the system.
Yeah, we have the participant level is such that if you have a problem, just say it. We can try to help you solve it. But it's nice to see that most of you already were able to get in, and it's also interesting to see it's research. Almost everybody's in research. Yeah.
Yeah, and feel also free. Like you can always turn on your camera or microphone, but we can also use the chat. Okay. Yeah, as Patrick already mentioned, we have a lot of people from research. And maybe for the next question, we can see in which country everybody is coming from. This is in a word cloud style. And we will give a moment to fill it in. We can see some people from France, from Belgium.
I would think also some people from outside of Europe, or not?
Well, there's the UK. I don't know if you want to count that as outside of Europe.
No, the UK is inside Europe. Outside EU, it's inside Europe, I would say.
Okay.
India. Ah, okay.
Yeah, that is definitely outside of
That's
Europe.
really outside Europe. Yeah.
Brazil.
Brazil, for sure. We have already 3 continents. Nice.
Okay. And then for the first question that is related to the LCA work, we were curious what current barriers are to perform an LCA.
Yeah. So what are the barriers that you think that are happening with which are you experience as problems in your LCA? Huh?
Yeah, we can already see that data availability is quite high. I think we've seen this multiple times.
Yeah.
In different sectors.
Yeah, I would think this is more prevalent in the biochemicals because, of course, you have many products with all different characteristics, and yeah, you have also lots of data you need to know about.
I was
Data availability.
curious there's one person who filled in other. Are you able to elaborate? Feel free to open your microphone to do so.
Or the chat, or well, the general gist of this question is quite clear. It is almost conclusive, almost completely data availability as an issue. Yeah, I can't say I disagree with that, but many cannot say that. Can we go to the next question?
Yes. The next question is regarding guidelines. So, which guidelines are you using for your environmental impact assessments that you are currently performing? It's nice to see people react so fast.
Yeah. Yeah, it's also interesting to see more and more people using the PEF, the product environmental footprint. And that seems to gain quite some importance. Mostly it's the ISO. That's the yeah, you can say the standard way of doing the LCAs.
if you do
Yeah.
PEF for EPD, you automatically already follow the ISO. So
Yeah.
I guess that's why they they add up.
Yeah, well, it could be yes. It's, but are there category rules for the biochemicals sector? I'm not sure actually. Maybe for some products.
I'm not myself aware of any category rules, but if anybody can explain more, or maybe you're doing it with outside of the chemical sector.
Yeah, of
I'd
course.
be very interested to hear in chat.
Yeah, I would assume if you have to make category rules for chemicals, then you need lots of categories, I think.
I think about everybody voted.
Great.
So maybe we can continue.
Very nice.
This was just a question about where do you find your information or your resources on how to perform an LCA?
It's a bit small, but if you have it on your phone, you can read it. I think. Yeah.
It's from left to right. It's handbooks, for example, ILCD handbook, social media, so YouTube, other sources, LCA community, scientific papers, information from dedicated projects, for example, aligned, or guidelines included in the LCA software itself, and other. And we have a very scientific-oriented community here, I see, because scientific papers is currently winning.
Yeah.
But it's very distributed. There are different resources.
Yeah, but I think also, we have a comment in the chat. Thank you for that. There are category rules for some products, such as plastic boards and sheets. Okay. For the plastics,
yes,
there are
plastic,
category rules. Okay. Yeah, and of course, if there are those rules, then usually it is beneficial to use the PEF because many things are pre-specified, and that helps you of course a lot in the preparation of your LCA. But indeed, scientific orientated and community orientated. People also learn from the LCA community. There are, of course, quite some nice groups on, for example, LinkedIn. And indeed, we see also guidelines in the LCA software. And of course, as I said, Aligned has also some guidelines on some interesting methods if you would like to try them out. Then the handbook.
Oh, I'm sorry.
The products, and not too much people from social media, but I think that will also gain prominence over time, because I think if you look a little bit for the YouTube videos, I mean, I don't think you should use it as sole source probably, but it could help you easily underway to perform those things. And well, it's a very nice user-friendly way to learn about it. Interesting. Yes.
And then the next question is regarding the motivation behind performing an LCA. I think this is quite interesting because what your focus is or your goal of doing LCA, it's quite heavily influenced by how you should approach it. Yeah, and again, we can see that scientific intentions are quite highly voted
will have
on.
something to do with our audience. If we have an audience which is working in research, then mostly you expect indeed scientific intentions. So
it's also interesting to see that customer request and consumer communication is voted on.
Yeah.
And there's no compliancy to legislation. So maybe the rules are less strict in the biochemical sector.
Yeah, I think the rules are quite strict, but maybe the rules do not require LCA.
Yeah.
I think it's many rules are, of course, related to safety and hazards and environmental spills, etc. And I mean, there's not so much a LCA question. It's simply a question that the material needs to not get in the environment.
Okay. Then we have the first question regarding the methodologies that we presented today. So one of the questions is, do you look forward to use the dynamic carbon accounting methodology?
Yeah. Okay, nice. Yeah, it's there is something to be said about the use of attributional or sorry, the dynamic carbon versus the easier method of 0, 0 or +1, -1. It is a little bit of more work, and there are limitations, of course, with respect to the sector. It's not that easy in the chemical sector.
We also have one comment in the chat about the compliance and legislation that are only pushing customers to get the LCA.
Yeah, and that I think that I could expect that to happen, for example, for the footprint of products. People have to show, I think, lower, or they have an incentive to show a lower global warming potential, for example, or lower toxicity, etc. Or that's not an LCA, but the lower global warming potential. You can do that with an LCA, and customers, I think, like to know that because they can also, make a good make money out of it through advertising or through like schemes which monetize carbon of lack of carbon emissions. So yeah, it's I think it's logical. I think you're right, Nama. Yes.
Then
I'm
now,
looking forward to see all these people use this dynamic carbon accounting methodology. I hope that is indeed the case, and you're not just being kind to not hurt our feelings.
Was it very difficult, Jurjen, by the way?
No, I don't think it's very difficult. It's the guideline, I think, is quite clear. So I didn't write the guideline myself. I just followed the guideline. The challenges that you come across are indeed the challenges that I showed, where you need to know something about the use phase. You need to know something about the end of life to make your carbon balance. But once you can make your carbon balance, applying this methodology is quite straightforward.
And if you look at the data requirements, do you need to not have a lot of data for the dynamic carbon accounting? Difficult to find data. Yeah, you need data about an average use.
Yeah,
phase.
it's more the use phase. So how long is your use phase, and do you lose any carbon there? Usually you don't lose a lot, so it's more the lifetime of the product. And then the end of life. So where does the product end up, and when it ends up in landfill, what happens to it? And that can be quite challenging to find proper data on. So in my case, I did a very simple model where I said everything that goes to landfill is anaerobically converted to methane, but that's of course not a perfect model. So finding data on that part can be quite challenging.
Yeah, I would say it's a worst case because I think many landfills are equipped with landfill gas collection systems, so that helps with the methane emissions.
Yeah, but even with these methane emissions, you saw that it has a very good impact. Like it further decreased the global warming impact of the product, which is more realistic.
Yeah. But about this use phase, I mean, how do you know how long a use phase is? Is that easy? Was that difficult to find, or?
Once I chose that epoxy was the use case, then you can find an average lifetime of epoxy quite easily.
Okay. Okay. Very good. Okay. Well, it's clear. It's not too difficult, apparently, or at least for you, not too difficult.
Yeah, I think we also have some questions later on regarding the use of an example product that you mentioned. If people think this is a good option.
Yeah.
One note on the previous results, I saw a lot is lack of expertise and training. So feel free to reach out to Aligned if you're not fully understanding certain guidelines or you need more input there.
Yeah. Yeah, and I mean, if you start something for the first time, of course you have a lack of expertise and training. And that's you have to start somewhere. Yeah. Well, the perspective LCA. Yeah, it's some people like it certainly, and some people don't. And I think there's also more to be said about this than just the binary, like it's great or not great. I think sometimes it can be very useful if you are looking like Nari did for what happens if our entire sector is going bio-based, because that's absolutely a question which plays out in the future. When you have a new technology, then of course it also plays out in the future or a long use phase, but sometimes it's not needed. If you have a process which is already at full scale and which is operating, yeah, and I mean, it can be a useful addition, but it's not a necessity. Huh?
Yeah.
So yeah.
If I may add, but you can have also a product that is already at full scale, but you want to know how the future economy, the socioeconomic scenarios can develop. So different narratives, the implementation of the nationally determined contributions, if the future goes more towards fossil-based energy, for example. So this is also one of the nice catches from applying life cycle assessment in a prospective way. And yeah, I was very curious to know who the two people that answer no, not at all. If it's like because it doesn't apply to the research they are doing, or because it looks too complicated, or what was the reason, if someone could write on the chat or say on the microphone. So maybe the answer here is I don't know if it's the same person, but probably the lacking of training or expertise and lack of prospective database availability. Yeah.
The database availability. Nari, please correct me if I'm wrong, but I believe that should not be the issue. Huh?
Yeah, it's all open source. And we have the guidelines from Aligned, but also the newest versions from Brightway and Activity Browser. They have some plug-in tools that you can do the transformation of these background data sets in a much easier way. So it doesn't, you don't need the prompt pages, you don't need any programming at all. So it's quite easier. And as I said, all the databases, they are open source, but you do need the license of EcoInvent, because these are transforming EcoInvent database, and then you need the license from EcoInvent. But once you have it, because you would need for a conventional LCA the same. So once you have it, then all the prospective things are open.
Yeah, so if you have a EcoInvent license and you have the EcoInvent database, you can use the aligned data sets and tools to obtain a database for prospective LCAs.
Yeah, but correct me if I'm wrong. If you have a temporary license, then it doesn't work, or am I?
I think it does, because once you have the transformed data sets, you can keep it.
Yeah, if you have a temporary license, there are some issues that you cannot download a certain version of EcoInvent that you need to convert. So then you run into some technical issues. That's correct.
Okay.
Yeah. Okay.
But if you have a running license, then it works.
Okay. But if you so if you have the EcoInvent database that's needed, you can download the transform database. And do you need to use the premise activity browser, or can you also use Sima Pro? Or
So you can use Sima Pro as well, and then there are the guidelines generated by Aligned. It's also including Sima Pro, and it's for the version of EcoInvent 3.9.1 or until the 3.9.1 that is there on the tutorials. But then the new updates also from Activity Browser, they allow to connect premise up to the EcoInvent 3.10. So 3.11, that is the newest EcoInvent, it still doesn't have the matching, let's say, for the prospective LCA.
Okay, so that will come later when the premise people are,
they're quite
up.
fast.
Okay. Yeah. And then Damien Arbeau, thank you. With a temporary license of EcoInvent, you can access all EcoInvent previous versions, but not the latest version. Those published after your license expired. Okay, good. Thank you for this addition. So if you want to do it with a temporary license, this prospective LCA, pay quite some good attention to your expiration date and what you want to do with these prospective LCA. Good. Just one more question on this. We didn't talk about it earlier, but Nari, can you explain the tiered approach used in the prospective LCA methodology?
Yes. So the tier 1, you basically have the more basic set of the shared socioeconomic pathways, the scenarios that can be, because there's a huge variety, right, of integrated assessment models, scenarios, and climate policies. So also in the tutorial, there's a table showing all the possibilities, but then tier 1, it's a more basic one with some pre-selected scenarios, and then tier 2, you can use a little bit of your own programming skills, but very easy to create or have more than one of the available scenarios and different years. And so you can have a more a better, like, defined by you perspective transformation defined by you and not from Aligned.
And tier 3 is you program everything yourself.
Yes, so it's even more more advanced.
Yeah. Okay. Very good. Good.
I think we should go to one of the final questions, time-wise. Yeah, maybe we can ask this
Can we
one.
do this question? Because this is, I think, quite important. Huh? It's about the approach. Which approach is most effective for assisting the environmental impact of platform chemicals? And platform chemicals are chemicals which can be produced in many products. And what Jurjen already said, if you want to do a cradle to gate, of a cradle to grave, you want to use, you want to describe the production of the chemical, production of the end chemical, and of course the end of life use for the final products. If you have hundreds of final products, it's not feasible. So you have to find a solution there. That's very sector specific. We did the exemplary final products. You could indeed use cradle to grade, so just omit it. And there may be other solutions. We're very open to that. It's if we have one if we know everything, we are finished. So we don't. There may be other ways to look at this.
Yeah, and if you say others, I would be very interested to hear from you in chat. What other solution you could think of?
Yeah, we would love to hear it.
And as with all the questions, if you want to think about it a bit more, you can also email us afterwards. That's of course also perfectly fine.
Exactly.
Feel free to reach out.
Yeah, well, I think your method, Jurjen, is the one which is well regarded, I would say.
It's good to see that I get I get some support for that. But I think there's also something to say for performing cradle to gate LCA and then give that to your customers who will then add their part, and in that way you get to a full LCA, especially when the demand comes from the consumers in the end. So it also depends why you're doing the LCA and where the LCA results are going to.
Yeah, absolutely. I think that's also a bit the comment of Mariana. It's the purpose of the LCA, cradle to grade during the design optimization of the product platform production technology. Then an LCA, a cradle to gate LCA. I think also an attributional LCA is a very good instrument. Yeah, and later on, you can indeed use other methods to do cradle to grade. Yeah. Logical. Yeah. Okay, this is helpful. Thank you.
Yes. I think then we can end with asking, what methodology do you look most forward to generally being implemented?
Yeah, and we have these 4 options. The dynamic carbon accounting, which was shown, the perspective was shown here, the consequential LCA as the alternative to the attributional. And yeah, we also, it wasn't really the topic here, but we also developed some guidelines for how to handle the uncertainty, or how to determine the uncertainty in your data, in your model, etc. What different ways are there to quantify that?
Okay. So while people are filling in, to add a bit on the uncertainty analysis, when you're doing a consequential LCA, CIMA Pro does not support the Monte Carlo calculation that I think most people are used to when you're doing uncertainty and sensitivity. Within Aligned, we have developed some guidelines and also some Excel files that you can use to determine your uncertainty when you're doing a consequential LCA. So that can be of help when you're running into this issue as well.
Okay.
And maybe with that said, the uncertainty analysis is increasing in popularity.
Yeah, interesting.
Okay.
Very good. Yes. Yeah.
Yes.
May I have just one question to Jurjen about this uncertainty analysis? You mentioned if you cannot use the Monte Carlo in the consequential, the Monte Carlo approach, there are other approaches. What are those? Which we are?
Yeah, you cannot use the Monte Carlo tool within the CIMA Pro software on a consequential LCA, but you can still use the Monte Carlo approach. So you have a sort of Monte Carlo approach, but then you do it within an Excel rather than within the CIMA Pro software.
Okay,
and we have a tiered system again, where with the tier 1 you do a very a more simple approach where you look at the uncertainty of the different life cycle phase. So you can say, for example, cultivation, use, and end of life, and then you determine the uncertainty of those phases. And you can also go into more detail and look at what are the most uncertain processes within your value chain. So depending on which tier you choose and how deep you want to go in your uncertainty analysis, there's different tools available.
Okay, and just one question about the Monte Carlo approach. What I liked very much, what is very interesting from the CIMA Pro tool, is you press the button and it calculates 10,000 opportunities. If you can't do that, how can you do that outside of CIMA Pro? Is there a tool which lets you run CIMA Pro 10,000 times?
Yeah, we cannot run indeed then 1,000 times the calculation. That's correct. That's not feasible outside of the software.
Yeah,
At least as far as I'm aware. Maybe there's people who have developed tools that do that using your CIMA Pro database, but I think then you need to make your model outside of CIMA Pro.
Yeah. Okay. Great. Clear?
Yeah, then I think we can ask if people have some final questions or remarks.
Yeah, we are nearing the end of the workshop. We have 1.5 hours is really, I think, also a nice time to end the workshop. But if you have any questions or remarks, I thank you very much, by the way, for all your inputs in the chat, especially. I think they're useful. We hope that you learned something. We hope that you gained some knowledge. And we will use your answers also in our work. We hope to update what we are doing so that it better reflects what people think about it. That's one of the reasons that we're having this workshop. Any other remarks from anybody? No? Okay, then we go to the wrap up and the next steps. I very much would like to thank Nari and Jurjen for their presentations, which were both quite interesting and relatively concise with the good information, which helps. Can you do the previous slide, Rachel?
Yeah.
Yeah. We will share proceedings from the consultations and the workshop with all of you, so that you can read it at your leisure and look at what you can do if you want to use the new methods. So we hope that helps. And also, we will use your information to update our sector recommendations so that the environmental sustainability in the bio-based chemical sector is improved, and also the methodologies are improved. So we thank you very much for that. And we would say have a very good rest of the morning to everybody. So thank you.
Yes,
Thanks,
and if you are
everybody.
interested, you can still join our stakeholder network, and you will get updates on the final results from the line project.
Okay, very good. Thank you for this last edition, Rachel. Thank you very much, and have a good day.
Thanks,
Bye-bye.
everybody.